All right, so we are going to look at the problem that says, my kids were throwing rocks off the cliff in our backyard. They were trying to throw the rocks over the cliff so they wouldn't land in the water. The cliff is 3.5 meters high and the creek is 2.3 meters wide. Ryann Elaine was throwing her rock with a speed of 2.5 meters per second purely horizontally. Does she clear the creek? Okay, so what is our object of interest? Well, we're throwing those rocks, so our rock is the object in motion. It's our object of interest. And when do we start caring about the rock's motion to answer the question of clearing the creek? And when do we stop caring? Well, we start caring when Ryann Elaine lets go of it. So lets go of the rock, and it goes flying through the air. And we stop caring when it lands, wherever that may be, and we want to know if it cleared the creek or not. So the rock is flying through the air. It's moving both horizontally and vertically, so it's moving in 2 dimensions. So this is a 2-dimensional motion problem. We only have one object, and since it's in 2 dimensions and free fall, it's single acceleration. So one phase, free fall, 2 dimensions. All right, let's draw a picture, define the world. So here we are on the cliff, and here's the creek, and there's the other side of the creek. So when we define the world in a 2-dimension problem, we have to recognize that there's both a origin we have to set for the vertical dimension and an origin we have to set for the horizontal dimension. So let's set the origin for the vertical dimension at the level of the creek. So our position equals 0 vertically, where everything in the world above is positive and everything in the world below is negative. We'll set it at the opposite side, the creek bed. Horizontally, let's set it where we're starting. So everything to the right of where we're starting is positive, and everything to the left of where we're starting is negative. So everything above the lower creek bed is positive, below is negative, and everything to the right of where we are throwing the rock, or Ryan is throwing the rock, is positive, and to the left is negative. Okay, so let's look at what we know in each of those dimensions. So x initial, horizontal, these are our same variables, players of motion, what describes the motion that we've been using the whole time. Oops, now we're going to look vertically. X initial vertical, X final vertical, V initial vertical, V final vertical, acceleration vertical, and time. All right, so our initial position horizontally is 0 meters. Now we want her to clear the creek, but we don't know if she does. So we actually don't know where it lands. We are told that she throws the rock purely horizontally at 2.5 meters per second. And we also know that horizontally we have a constant velocity. So our acceleration horizontally is 0, always in 2D projectile motion, without any air resistance. And we don't know our time. All right, well, what about the vertical direction? Well, we're saying it's starting not at 0, but at the level of the cliff, which we're told is 3.5 meters high. So if the bottom of the cliff is 0, the top is at a positive 3.5 meters for position. It does end at the bottom. We don't know how far, but we do know it gets to the bottom. V initial, well, it's purely horizontal, so our V initial vertical is 0. We don't know our final velocity, but we do know we're in free fall, so we're accelerating in the vertical direction at the rate of g. And here on Earth, of course, and we don't know the time. Okay, so to answer this question, we want to know if Ryan clears the creek. So that is our final position horizontal. So x final, we know, is equal to x initial plus v initial t plus 1/2 at squared. X final, that's what we want. We're starting at 0. We have 2.5 meters per second as our initial velocity. I don't know my time, but my acceleration is 0, so that term is going to go away. So x final horizontal is equal to 2.5 t. I need t to solve this problem. Well, fortunately, the object is moving vertically in the same amount of time as it is moving horizontally, so I can look for t in that dimension. All right, well, we're going to use the same relationship we did up there. X final is equal to x initial plus v initial t plus 1/2 at squared, because I know the values that are in that equation, except t, so that's why I choose that one. X final is 0. X initial is 3.5. V initial is 0 times t, that term will go away, plus 1/2 negative 9.8 t squared. And I'm left with 0 is equal to 3.5 minus 4.9 t squared. Bring that 4.9 t squared to the other side and solve for t, and I get, 0.845 seconds, which can go into my lists and into my relationship for the horizontal position. So x final horizontal is 2.5 times 0.845, and that equals 2.11 meters, and Ryan needed to get 2.3 meters. Sad. She doesn't make it across the creek. All right, so recognizing that we have two-dimensional motion is key, that we're only moving horizontally at the beginning, so our initial velocity is 0 vertically, and that we're dealing with a state of free fall. All right, good job.